And I think we are live now. Who do we have here already? Santiago Abdullah, of course. How are you guys doing? Joining early. Did you guys arrive on the chat before I arrived in the room? Talking about TDS, there we have tons of strength, but could it be possible to include yield strength too? Yes, that's a good question. We are going to talk about it today, like what kind of data we're sharing. I mean, there could be like a long list of data that we could put. We also thought about putting the stress strain curve directly so that you can look at exactly what you need. But unfortunately, we realized that the exact stress strain curve for a material is quite a sensitive information. It is possible for someone to have it if they have the machine, but we don't want to share it publicly, or at least not the one we do with our machine, because it can reveal a lot of things if you have an accurate device. We have Noah here. Hello, thank you for joining as well. So we have a first topic. Like I said in the last stream, I will try to talk about that topic first, and then let's say 10 to 20 minutes, and then we can jump into some more open topics. We can talk about some of the questions you have, and then the good thing is every time I come, my team just set up the table, and then usually I just do with what I have, and it's pretty interesting today because I've never seen that, but it looks like we have a whole plane on the table. Some parts I don't even know where in the plane it goes. I guess that's where there is the wings, I guess. Oh no, I think that's the back. I think that's the back of the plane. But anyway, we have a plane today. We have all our lightweight color, and of course we have a Valentine's Day. Can you, without the reflection, be mine? So it's pretty nice to come to the office at 11 o'clock in the evening, and then you arrive, and then you have this on the desk with a lot of interesting print inside. So, we have Maker Millwright that also joined, and we have Matt German here. So this live stream, like we said last time, around once a month, we are going to have one more with a time that is a little bit more friendlier for Europe. So I guess we will have a little bit more people from Europe as well. Actually, if you could share where you guys are based, like where are you watching the stream from, and what time is it in your country? So I guess we will have some people from both parts of the world. We have Asia here, we will have Europe and America. So I tweeted Nick and I tagged Polymaker. Thank you. Yeah, and if you could share also that we are live now. A lot of people because I shared before, and then a lot of people just forget. So it would be great that if you're on Twitter, Instagram, or Facebook, you just share that we are live now. And then once we will have a little bit more people coming, then we will start to talk about our different topics, because I know sometimes it takes a little bit of time for some people to join, and I don't want them to miss the beginning. So we have some people from the UK. Matt German from the UK, 3 p.m. Okay, so my GMT +0. We have from Germany 4 p.m. Okay, so you guys, so that's for you that we are making this special time live stream. So I'm very happy that you guys are able to join. Even though I think I've seen your name in even the regular time that we do for the US. So I don't know what time is it when you're watching that, but it must be pretty late in the evening, yeah, or early in the morning. We have Colombia, Santiago, of course, 10 a.m. East part of America, 10 a.m. from Collie Logan, Vancouver, Canada, and 7 a.m. Ooh, you woke up early. Woke up early on a Saturday, right? Should be Saturday for everyone. I think it's Saturday for everyone, whether it's morning or evening. Matt German, 3 a.m. in the morning. Yeah. So that's why I want to do some stream with a better time for you guys. So you guys make the effort when I do the regular time for the US, and now I make the effort. It's what? It's 11, yeah, 10 past 11 p.m. here, and I just drive. I just take my scooter, drive to the office, and then I can have you guys on a better time for you. 7 p.m. in Mauritius from Abdullah. Oh yeah. Abdullah also joining very frequently. Great. So today the first part is TDS. Why I wanted, I actually printed one out because I still cannot share my screen. I need to set up something so that I can share my screen, but I printed out. So I don't know how many of you are using. Oh, My Tech Fun. Thank you. My Tech Fun that has again a very nice YouTube channel. Igor, if I remember well, that is creating a lot of very technical videos. So I'm very happy that he's actually joining because we're going to talk a little bit about technical stuff. So maybe he will be able to bring his input as well. Hungary is 4 p.m. Perfect. So I'm glad that we have a lot of European that are joining. That's mainly for them that we are placing this live stream in this time slot. And by the way, Igor, I sent quite a lot of spools. I think I sent the whole Polylite family again, plus the Polymax family. I know you already have some spool, but if you're doing some technical stuff, then it's better to have like all the fresh spool. So hopefully you will have enough to do what you wanted to create it. Comparison video, if I remember well. And today we can talk about the different things that differentiate materials. So why I wanted to do this topic, the TDS, is because I've seen a lot of people talking about strong filaments, and I notice a lot of people have difficulties to define what is strong. So a lot of people they are asking me, what is your strongest filament? And when I ask them, like what, so why I'm confused when someone is asking me what is the strongest print, the strongest material. The main reason is because there is at least there is around four type of strength, or let's say 5 if you add the shear strength. You have the tensile strength, so how strong a material is to resist pulling. So tensile strength is in the direction of your well, here actually I have specimens of your specimen. So the tensile strength, you are just going to pull the material apart. So how strong the material is to resist that. And then in the tensile, you have the tensile strength and the tensile modulus, which is the ratio. But we can talk about that after. So you have that strength. Another strength you have is the bending strength. So how strong the filament is to resist deformation perpendicular to the specimen. And what you can notice is when you do a bending strength, you actually include tensile strength at the top and compression at the bottom. But let's talk about bending strength here. What's the ability of the material to resist the bending? Another one is the impact strength. So impact strength means how does the material resist to a sudden load. So usually we are using the Sharpie impact or the Izod. We are using a big hammer, and then we are just hitting the model. So it's not the specimen. There is another specimen which should be actually on at the end of our TDS. By the way, you can download all the TDS on our website. So there's no way I can show you, but basically it's a smaller part. Actually, if you go on Igor's video, I think he's printed the exact one. And then you have the hammer that is hitting, and then you're just calculating how much energy the material is going to absorb. Another one is torque. Torque is similar to the bending strength. It will involve a different kind of strength, which is the shear strength. So when you have torque is when you try to twist the material, how the material will resist the shear strength. So shear strength is this, right? the molecule are going to go in a different direction against each other. So that's more or less the 4 type of strengths, if we want to summarize it in a simple way. So depending on the application, some of the strengths would be more important than other strengths. So let me catch up a little bit. So we have Matt German that says that he liked PLA and PLA plus. So again, the good thing is to understand what is the difference between I think I have here some between PLA, a regular PLA, and what we call a PLA plus. It's very important to understand what do we mean by PLA plus. Some people mean PLA plus is a stronger material, but how strong? Is that the tensile strength is higher? Is that the impact strength is higher? The bend stress is higher? How strong? How do you define how strong the PLA plus is? Some other people define PLA plus as it's easier to print. It's a premium PLA. But the most important is you can define. If a company tells you our PLA plus is easier to print, then you should ask why. Why is it easier to print? What's the difference? Is that the melt index is higher, so it makes it flow better? But then you have some other problem. If it flows better, you may have worse overhang. You may have problem with cooling, so you don't have a good surface quality. So it's always important to define properly what company are trying to tell you. Why we share our TDS is because we want to be transparent about the material. If we, for example, we have our Polymax PLA, and then we have our Polylite PLA. So we are saying that our Polymax PLA is tougher. Even the toughness has many definitions. You can have, let's say, the fracture toughness, which I think is more defined as a sudden load. And you can have tensile toughness, which is more a slower load. So there's different kind of toughness. So we are sharing the TDS so that you can compare what's the behavior between the two PLA. So I see a lot of people saying PLA plus is better, but depending on which company the PLA plus come from, then it might be different. Like, for example, for us, the Polyterra PLA plus compared to the Polyterra PLA, it's not a better impact strength. Well, the impact strength is similar, maybe a tiny bit better, but the most important is the modulus. Why our PLA plus, the Polyterra PLA plus is better than the Polyterra PLA is because the modulus is higher. So it's slightly more rigid. If you have used, I think it's this one. If you have used Polyterra before, you will notice that it's a very ductile material. It bends pretty easily. And the Polyterra PLA plus has more difficulties, so it requires more energy to bend. And that's how we define the PLA plus. For the Polymax PLA, which a lot of people call it a PLA plus, which is fine, but it needs to be defined. The Polymax PLA doesn't have a higher modulus than the Polylite PLA. So it means it's not more rigid than the regular Polylite PLA. Why it's called a PLA plus? It's a Polymax PLA. It's because of its toughness. The tensile toughness of this material is way higher than this one. So if you went to do a tensile strength on Polymax PLA compared to Polylite PLA would take more load, so it would take more energy to break it. But however, it will break pretty early. The Polymax PLA may not take the same amount of energy to break, but it will deform. It will have we call this a necking, where you have the deformation in the middle, and then it will take a long time before it breaks, and even more similar for Polyterra PLA. So all of this to say that when you say PLA plus, it's very important to define it. If you like it, great. Which part of the PLA plus are you the most interested in? Because we can also make a PLA that is easier to print. It has to do with the viscosity of the material. You can make a formula that help with the printing, playing on the rheology of the polymer. some PLA Plus has this. Our new colors of Polylite PLA is using a formula that makes it much easier to print than the older version of the Polylite PLA, which was a long time ago already. But we didn't call it PLA Plus. We thought that a regular PLA should print well already, and PLA Plus for us is more on the mechanical property. Is it just me, or is the stream breaking up? Oh, really? Is that coming back now? Yeah, no, it should be fine because not a lot of people use internet at this time in China. It's pretty late, and nobody is in the office, so yeah, I'm not sure. Let me know if it's still the same. My tech fan, thank you. Yes, comparison video, my standard mechanical test of the whole Polylite line. Next move to the other type. Yeah, so it will be very interesting to see the video. So my tech fan, so Igor over at my tech fan is going to do a video comparing the different Polylites, so Polylite PC, PLA, ABS, ASA, and PTG. And it will be very interesting to see what's the difference between the material according to the different stress. But another point that I want to highlight is the TDS highly depend on how you print your specimens. So this is the specimens that we are printing, right? And then we are doing the test with it. The problem or the main difference with injection molded is depending on how you print, the result, even if you're using exactly the same testing standard, can be very different, especially for a high temperature amorphous material like ABS, ASA, or PC. Depending on how you're going to print it, the result of the test can be very different. So why we have so many versions? I think this one is version 5.1 or maybe even 5.2. Let me check. That's the Polylite PLA. Yeah. So this one is 5.2. So why we have so many versions? Because we are continuously trying to find a better way to standardize the way of printing. So right now we arrive at the point where we are using a printer, so the same printer for all of them, and then we are changing the gear and we are changing the nozzle every time, because even the nozzle and even the gear wear is going to affect the mechanical property. If you have some small defect, then it can act as maybe 5% or even a 10% loss in the mechanical property. So in order to be fair, in order to being able to compare material, then we have to standardize to a certain level in order to compare the material. So actually, that's kind of that's one of the purpose of the TDS. One of the purpose of the TDS is that you can compare material with each other. For some of the engineer, they are interested in the absolute value for their calculation, but most of the people, they are interested in comparing two different material. You know why I had this idea about the stream is because I saw a tweet from I don't remember who, but I saw a tweet that were comparing another PLA. I think it was Izod PLA Plus, and he was comparing this one with our, if I remember well, it was our PLA Pro. I think it was yesterday or 2 days ago, and he was saying the Izod PLA Plus was way better in terms of the tensile strength than the PLA Pro. And when I saw that, I was surprised because we put a lot of effort in the PLA Pro, and from our test, it should have been one of the best on the market in terms of balance between all the different strengths. So I went to look at his tweet in more detail, and then I saw the TDS from Izod. And so first, it's very difficult because there's no testing method, and second, I'm not sure whether the specimen was injection molded or was 3D printed, and I don't know how they printed this material. So it was very difficult to compare. So what we did is we printed all our materials plus other materials on the market in order to compare with exactly the same the same setup. Now the other question, by the way, the answer is that PLA Pro has a higher tensor strength and a higher impact strength, but maybe it's biased. It would be great that a third-party company can do this test, and that's exactly why I like the channels like MyTechFun or CNC Kitchen or other technical channel, because they provide a third-party test. They have I think both MyTechFun and CNC Kitchen, I think they both build their own testing system, so they have control over their testing method, and then they can have different material, and they can exactly compare two different material and then give unbiased result. Because even if we give the result, even if we say it's it's the same testing method, etc., I think it works much better if a third party is doing it. So that's why I like supporting this kind of content and test. Now there's another question: how do you compare? Let's say I have two PLA. Let's say it's regular PLA. Let's say it's Polylite PLA, and let's say it's another brand PLA. How do you choose at which temperature you are going to print this PLA? Because on one side, you may have a PLA that recommends, let's say, 210, and another that recommends 200. Do you use the recommended printing temperature and then you compare them, or do you use the same temperature in order to compare them? Well, that's another great question. For us, what we do is, or what we are trying to do, because we haven't figured out exactly, is we are trying to use the melt index. The most important is that both material had flow the same way during the print. So you have to print at the temperature at which both material will flow the same. Why flow the same? Because then you will end up with exactly the same material. There is still some issue doing that, but it's much better than, for example, just taking the same, let's say, the recommended manufacturer temperature, because on one side, the recommended one can go from 190 to 230. So which one to choose? And on the other side, it can highly depend on, what the manufacturer wanted to highlight. If he wanted to highlight you can print at low temperature, he will recommend low temperature. If he highlight that it's very strong, he will usually recommend higher temperature. So that's today I want to talk about all these challenges when making a TDS. Let me hydrate a little bit. So let me catch up a little bit with if you guys have some question. So we have some discussion. Okay, Matt German, I do lithopans and work mainly with white filament. Yeah, lithopan are wonderful. I think the best for that is to have a filament that has a very, very good diameter consistency. If you have a good diameter consistency, then you have a very nice thin wall, because the lithopan is going to highly depend. The lithopan quality is going to depend on how accurate the thickness of each layer is. So if you have a good filament, then that can provide very good lithopan. Maker Mealwhite, what product has the strongest impact, and which is the strongest steer PLA? What does steer mean? Do you have the French word for that? Steer. Let me check. A piece of advice or information concerning the development of a situation. Control the movement of a vehicle operating. What does, and which is the strongest steer PLA? Sorry, I don't understand the second one, but the strongest impact. So if we are talking about the Sharpie impact strength, if you go on our Polymaker website, us.polymaker.com, then you have a tab that is called Material Comparison. And then I have it in front of me. And then there you will have graph. And then on that graph, you will have the different, all our materials with the different properties. So if I go on the chart that says durability vs rigidity, so you have durability on the y-axis and the rigidity on the x-axis. If you go on the top right, you have Polymaker PS6CF. So in terms of durability, which is represented by the impact strength, which is the Sharpie impact strength. So you can check the standard, the ASTM that we are using, and the Polymaker PS6CF wet, which means it was conditioned, moisture condition, is the highest impact strength. So in terms of absolute impact strength, that's our PS6CF. So let me go back to our chat. So Matt German, way to undersell. What do you do? I think Polymax PC and Condition PS6CF have the best impact strength. Yeah, actually, Santiago already answered the question. Polymax PC does have a higher one, but if you look at the chart, is the third one. You have Polymax PS6CF at the very top, and then almost at the same level, you have Polymaker PC ABS and Polymax PC, and then you have PS6GF. Then you have our Copier, and then the other materials. Matt German is answering, make a wheel run, and then we have Abdullah. Is it possible for you to do both Izod and Sharpie for the same filament? Polymaker uses Sharpie while Eason is using Izod, if I remember correctly. Yes, this is correct. Eason, I think, is using Izod, and we are using the Sharpie impact strength. So I think the difference is the Sharpie, you are only holding the specimen from one side, and then you are hitting it with the hammer. For the Izod, I think you are holding it with two sides, and then you are hitting it in the middle from memory. Matt German, I need PLA. What is heat resistant? So you need a PLA that is heat resistant. So basically, you need a PLA that can be annealed easily afterwards. We can talk about this in after we finish this topic. How to anneal, like how to get heat resistance with the PLA. Santiago, my tech fan, I think the result between Izod and Sharpie are not the same for a given material. Yes, actually, I checked, and a rule of thumb is that the Izod will always be slightly higher than the Sharpie. But I checked very quickly because I wanted to find a way whether it's possible to compare them. The straight answer, the short answer is no, you cannot compare them. But if you had to, usually the Izod will be higher than the Sharpie, if I remember well, or the other way around, but something like this. I think the Izod was the higher. Isaiah, I think that's the first time I see you on the stream. Thank you for joining. So I guess you are from Europe. If you are joining on this specific stream that is more for Europe, the stream is fine. Thank you for confirming. Abdullah, also stream is okay. Great. And then we have some discussion between Santiago, Make a Meal Right, and Abdullah. Igor is saying to Abdullah, sorry, no, I build my equipment for Izod impact strength based on the ISO 180, okay? But at least my tests are the same for all materials in my experiments. I don't have the hammer for Sharpie. Yeah, I mean, at the end of the day, that's the most important. The most important is all the tests are done exactly the same way. And then you can compare them with each other. And then we have, sorry, I jump in the chat. Claro. Also, Clara, I think that's the first time I see your name, is it? I don't know if it's been asked, where do you get files for print specimen? Usually we model ourselves because we have all our dimension in the TDS that you can print on our website, and then we just design them ourselves. It should be pretty easy to find them online. You can go on Thanks 3D or Thingiverse, and then you type tensile specimen, and then you should be able to find this this dog-shaped specimen. And then we have Claro dimension. I mentioned in the TDS. Yeah, exactly, Abdullah. Yeah, it's pretty easy to design. You have all the dimension, but I'm pretty sure it's available. You can go on Thingiverse or Thanks 3D you can type specimen or tensile specimen or impact specimen, and then you will definitely find them. Santiago is answering to make a meal right, and then we have Abdullah. I'm interested in Izod result for Polymaker, so I guess your test should be fine. Yeah, definitely. Most important is exactly the same test in order to compare them. I have compared the gold silk from Polymaker to many other companies. It seems to be the most tough gold on the market. Oh, that's good to know. I haven't done. We have a gold here. We have our silk. I believe this is the silk, the Polylite PLA silk gold, and the toughest. I think it's the toughest silk. I think all the silk should be tougher than the regular one because of the formula. Because yeah, the Polylite PLA and the Polylite PLA silks is not the same formula. So yeah, Igor, if you are doing some tests, you can check whether the colors are using the same formula. So a color to another has pigmentation difference, but usually that doesn't impact too much the TDS. We've done some tests, and it doesn't change too much. However, some of the color are using a completely different formula. I mean, not completely, but it is a different formula. So you may want to test this one differently. That's the reason why our Polysmooth, which I don't remember which one. I think this one is the Polysmooth, or this one. The Polysmooth, the TDS, if you go and check, there is two TDS. There is one for the transparent, and there is one for the colored. Why? Because we noticed such a big difference between the transparent color, the result, and the colored one. So that's why we decided to do two different TDS. So even the color can impact the TDS. But it's good to know. Good to know that our silk is, from your test, one of the toughest silk on the market. Tough is good. Why the impact strength, the toughness of the material is good, is because it kind of represents the durability of the material. Like you're going to play around with it, you're going to drop it. It will be the usually. Colin Logan, the nozzle can definitely make a big difference. I tried the chip nozzle once, and I could get nothing to print. Switch back to an E3D nozzle, and it printed amazing. Nothing else was changed. Yeah, nozzle is very important. That's how you realize how hard it is to make a TDS, right? Because 3D printing, the process itself, so many factors influence the process that is very hard to make exactly the same from one filament to the other one in order to compare them. So you can imagine the work Igor is putting into the video in order to provide such an accurate way of comparing materials. We have Make a Wheel Right that is answering Santiago. You are so helpful. Yeah, definitely. I mean, I'm so happy Santiago is always helping with answering the question faster than me. Try the Polymax variant and the regular. Okay, some discussion there. Izia, so far I found that Polymaker matte PLA, the Savannah Yellow, print best at 230. That's the hottest I've ever printed PLA. It seems to work. Yeah, I mean, might depend on the printer, might depend on a lot of things. You may print at 230. I usually print the Polyterra. All of these, the small animals are printed with Polyterra, and I usually print them at 200 because the lower the temperature, the better the overhang. So I usually print all of them around 200. And that's actually another thing. You know, in our TDS, we have one part that says recommended printing setting. So recommended printing condition. So on that you have nozzle temperature, build surface material, surface treatment, build plate temperature, cooling fan, printing speed, rough separation distance, retraction distance, retraction speed, chamber temperature, threshold overhang angle, recommended support material. So we have a lot of recommendation, and hopefully this is to help having a kickstart profile, because we don't want people to tweak too much with our material. So, but you can see I have Polylite PLA in front of me, and we are saying from 190 to 230, which means depending on the application, depending on the printer, depending on a lot of things, then one temperature will work better than the other one. You know, I've seen something on Reddit. A guy says, so there is someone that was talking about his printing setting for PLA, and he said he printed his PLA at 230, and then a large part of the community in Reddit was saying, oh, this is not PLA. If you are printing at 230, this is PETG. But that's not correct. It's not because you are not using the temperature that you are using for this material that it's not this material. A lot of people say that if it requires 230 to print, then it's not PLA or it's not real PLA. First, you know, you have to define what is real PLA. There is so many different grades of PLA, and some of them can even print at much higher temperature. The most important is the print. That there's nothing to do between the temperature at which you print and what the material is. Or like you cannot find out what the material is by the printing temperature. So I think it's important to highlight here, whatever the temperature you're using, the best is the printing result. If the printing result is great, then that's the temperature. If you need to print at 270 and it's PLA and your printer cannot hold 270 too much, then yes, 270 seems to be the great temperature, but it's not good for my printer. So maybe this particular PLA is not good enough for me, but it doesn't mean it's not a PLA. So I just wanted to clarify this point a little bit. The shear value. So which one has the highest shear strength? Unfortunately, we don't have a way to properly test the shear strength of the material, and I think it would be very, very difficult for a printing material to test reliably the shear strength. So yeah, we don't have this value at the moment, and I don't think we are going to have it in the near future. Is it just a coincidence, or is the stream topic partially inspired by that tweet where someone said Izod PLA Plus is better based solely on the datasheet? Yeah, definitely, Noah. I mean, I just said it a few minutes ago. That's definitely for this reason. Maybe because I want to protect a little bit the Polylight PLA Pro, because in that tweet, we see Izod PLA Plus was basically here, and then PLA Pro was here. It was like 12 times better. So yes, I want to defend a little bit our PLA Pro. We put a lot of energy into that filament, so I just want to clarify. At the end of the day, you know, you can make your own decision on which one is right. What I'm saying, whether it's right or not. But I just wanted to add a little bit more, science explanation behind that tweet, because you only have a few characters in the tweet, so I couldn't explain entirely what I wanted to say. So I just make it a topic for the stream, so that I have full time to explain properly what I want to say. Abdullah seems to be inspired by that. 100% inspired by that. Actually, today's topic was supposed to be multi-material. You know, we had multicolor before, and today was supposed to be multi-material, multicolor, multi-material. But when I saw that, I thought, I think it's important that I clarify a little bit how to read a TDS. Otherwise, a lot of people would go and download whatever TDS from whatever company and then just check both number, and then this number is like 100 times bigger. The material is 100 times better. So I guess a few clarification was had to be made. Claro, I'm new to the community. Perfect, thank you. Yeah, thank you very much for joining, Claro. Usually we are streaming once a week, and what we are trying to do here is to talk science. We are going to we are dissecting 3D printing part by part and explaining the science behind. We are a little bit more material oriented, but sometimes we talk a little bit about the hardware as well. Santiago helping with the question. Thank you. Matt German, do you put the filament under a microscope? Yeah, very often. Very often we look the material under the microscope. Actually, if you have a microscope, check out Polyterra. try to break Polytera part and try to put under the microscope the fracture surface. So the surface that is created thanks to the energy that you are using to break it, and you will be surprised. I won't spoil you. I won't spoil the result, but you are going to find very interesting things if you do have a microscope. My tech fun, comparing same material in different color, great idea, but I believe the difference will be very small. Maybe the moisture or similar will deform the result, but I will think about that. Yeah, I mean, what I was saying is do not compare different color. I don't think it's a very good idea. It's pretty similar. We have done the test and it's very similar. What I was saying is some of the material are different. The silk PLA and the regular PLA are two different color, but they are also two different formula. So my recommendation or my suggestion was, if there is two different formula, then better do two different tests instead of testing one color and saying that this color, the mechanical properties of this color is similar to all the other color. So that was just my suggestion. Santiago, you can release internal stresses, but it won't crystallize. Okay, so that's part of the discussion, I guess. Noah is saying, depend on where and how the printer measures the temperature. Yes, also it also depends on where is the sensor. Although I think most of the printer are using the thermo sensor is in the heat block. Most of them are in the heat block. But at one point, I had some customers that has issue with under extrusion, and I told them, when you have under extrusion, it's very easy to solve it. You just use a crazy temperature. If you are printing with PLA and extrusion, the best thing to do is to use a very high temperature. If with the very high temperature it prints fine, then most likely something wrong with the hot end. And what happened with all of these customers is that they took apart the hot end, but they didn't put it properly, and the heat block was not tight enough to the nozzle. So you had to hit the heat block much higher in order for the nozzle to reach around 200, 210. You had the heat block to be at 270. So you just had to tight more the heat block to the nozzle so that the temperature can be transferred easily. So yeah, just one tip for under extrusion issue. Under extrusion is either something wrong with the nozzle, there is a clog somewhere, or it's because of the viscosity of the material. Okay. My tech fan is answering Matt German by saying, what would you like to see under the microscope? Sometimes I put broken test specimen under digital microscope, but otherwise don't know what to look for. Yeah. Igor, we are doing exactly the same. Every time we break something, we are putting it under the microscope, and this is how you can find out some interesting breaking behavior. Make a meal right is asking, I have been testing, but the Polytera is quite resistant to shear. I want to try a couple of different types now. Okay, Polytera is quite resistant to shear. Let me think. Yes, I think that could make sense. I have some ideas because of the formula. There is a specific part of the formula that could explain why it is more shear resistant. But still surprising though. Still surprising. My tech fan Nicola, you can do a shear stress on the same machine as the tensor strength. You can see the shear test in most of my testing video. Okay, so you mean, I get what you mean. So basically you're printing, I guess you're printing a cylinder, and then, so one part is taking here, the other part is taking here, and then you're just putting them apart. So you are doing a 3-point bending test, but very close to each other, and then you are doing the shear stress, or maybe on 2 part. I will check again your video, and then I will check how you do the shear stress. I guess my point was how to interpret the shear stress, in what, like how the user would need the shear stress, in what application it could be interesting. But I can think a little bit more about it. Make a mirror. I have been testing. Yeah, okay, I got that one. Noah, I think you mentioned that Izod didn't even state whether the specimen were printing or injection molding, which make a huge difference. Yeah, I mean, to be honest, I haven't went to the website. I haven't downloaded. I don't know if you can download the TDS, but I didn't download the TDS. I didn't investigate a lot. But on the screenshot that was shared, I couldn't find any information that was saying that it was injection molding or 3D printed. And if it's 3D printed, then in which direction, X, Y, or Z? So all this information, I couldn't find it, because I know a lot of companies are just putting the TDS data on materials. The raw materials they are using for the PLA, the PETG, they are just copy pasting the TDS. And the problem is it's injection molding. I mean, there is a huge difference between the TDS of the raw materials you are using, that is using injection molding, and the TDS after you process the material and after you 3D print it. You process into filament and then you 3D print it. So if you don't have all of this information, there's no way you can compare two different data. My tech fan in C under microscope on PLA, whatever, blah, blah, blah. Okay, answering to Igor. People compare numbers way too often without questioning where the number came from. Yeah, you're right, Noah. And we are here. You know, when I'm talking to R&D, quite annoying, because I keep asking why. If they tell me, yeah, this we created a new PLA, it's better. Why? It's stronger. Why? What kind of strength? The tensile strength is higher. By how much? Why is it higher? Oh, it's higher because we changed the formula. What did you change? Oh, it's because of the process. I always ask why? Until I'm convinced enough, until I have enough information to link both sides, like science and the result. Once I have this, then I think, yes, we can say this material is stronger. As long as I cannot scientifically prove that this part is stronger, if I cannot define what strength, then I won't say that it's stronger. So that's what I want to do here during this live stream. I want to question everything. I want you to come to me with questions. I want you to challenge whatever we are saying. Why we are saying our lightweight PLA is better than other lightweight PLA. Why we are saying passive foaming is better than active foaming. I want you to come with challenge. And with this challenge, we are going to increase our knowledge. Maziri, thank you for another interesting live streaming again. Yeah, thank you, Maziri. I think I've seen your name in other stream as well. I hope to make more and more interesting live streaming. Make me right. I have to go get ready for my stream. But thank you for chatting material mechanics with that big respect. Thank you for joining. Thank you very much for joining again. And so you're live streaming. I need to find time to join your live stream. I don't know if you are still there, but if you're still there, just drop your. Are you making a weekly live stream, a daily live stream? If you have some of the schedule, maybe I can put one of them in my schedule so I can drop by as well. But thank you for coming again. Santiago, I think ductile materials failed by shear. On the tensile strengths, they break with a 45-degree angle, which is the plane at which the shear stress is maximum with a pure tensile load. And Polyterra is quite ductile. Okay, so you're talking about we need to be careful with the way of testing the shear strength with ductile material. Is that what you mean? It would surprise me if it's shear resistant. Oh, okay, no, sorry. You are talking about why Polytera would be shear resistant. Ductility, okay, relationship between a ductile material and shear resistance. Okay, I understand. My tech fund, my hook in Polymaker competition fell under the shear stress. Oh, okay, now I remember. Now. Actually, Igor entered our competition, the hook competition. I don't know how many of you joined that competition, but it was in the end of 2020, if I remember well. It was an amazing competition. We learned a lot. And yeah, by the way, do you guys have some ideas of other competition like Igor? Do you have some ideas of interesting competition that we could do? I don't think we are going to do another hook competition because we already have like the winners and we know like the kind of design they use. I had an idea of a competition that we could do. Let me know, guys, what do you think about this idea? The competition would be to print. So I like to play with the words because I like to. I like people to be creative with the rules, and that's why I made very specific rules in the last competition. So the rules would be something like this: you have to print a model that will be dropped. So you print something, and then we will drop it from a certain height, and then we would check after it reach ground. So after of the plastic, the model reach the floor, we would check which so how high it can bounce. But how we are going to check how high it can bounce? We are going to check the plastic part from the model that will go the highest. All the data of the materials on their directory, so that you guys can compare. Masiri, thank you for the shout out. My name, yeah, you're welcome. Stream froze. Oh, it's just me. Okay, a problem with the live stream. Okay, let me check. Can you guys hear me well? Is that back now? Okay, Santiago is saying it's back. Noah is saying it's back. I guess the rules are still so secretive that the stream froze for security reason. Oh, really? So all the all the part with the rules that I was talking about, nobody got it. Oh, really? No way. I talked during like 5 minutes. I was saying all the rules of the competition. You guys got none of it. Like zero. We heard the start about the rules. Okay, so let me let me go back to the beginning. So there are no rules. Okay, yeah, I was thinking there's nobody chatting. There's nobody because the rules was a little bit strange, and I wanted your feedback, and nobody was answering. Okay, so the idea was to print something that will bounce the highest possible. So you can decide whatever material you want to print, whatever Polymaker materials you want to print. And then we would take that part and we will drop it from a certain height. However, there is no mention on how we are going to put the part. Like, you cannot tell us you have to drop it from this direction. we will drop it from a random direction. And then we'll drop it on the floor, and then we will check how high it bounces. However, the way I'm going to formulate the rules will allow you to find some ways to design a very smart one. So the way I'm going to check how high it bounces, I'm going to check the highest piece of plastic after the main part touch the ground. So I don't know exactly how I'm going to formulate, but basically it has to be one piece. So everything has to be one piece. Okay, so you cannot have two pieces combined. It has to be one single model, and this single model will be dropped from a certain height at a random direction. And then as soon as this part touch the ground, we are going to monitor the part, and the highest, like the highest point will be counted as the highest rebound. So there is, I don't know if you guys caught it. I won't say it, but there is a way that you can stay within the rule, but you can go much higher, maybe even higher than where I drop it from, just by thinking. Like, why I like the hook competition, because the hook competition was ingenuity and creativity, and I want to continue that. I want to give you rules where there will be some engineering involved. You will have to design in a certain way. You will have to choose a good material for that purpose, but you will have to be creative. You will have to read properly the rules in order to be creative for that. So yeah, what do you guys think about this kind of competition? Or maybe do you guys have some other ideas similar to the hook competition? Abdullah, how many materials type submission per entry participant? One model, one material, so just one entry per participant. Matt German is bad again. I'm so sorry. I don't know what is happening. I will try to upgrade our Wi-Fi in the office, or I will try to have a separate Wi-Fi just for the live stream. I'm very sorry that that is choppy like this. Igor is saying a TPU sphere 100% infill support or post-processing allowed. So TPU, that's your choice. 100% infill, that's your choice. If you think that's the way it will bounce the most. Support, yes, support will be accepted. Post-processing will be accepted. However, what we won't allow is any additional materials. So you cannot, for example, coat it with something, because that's going to be an additional material. You cannot paint it because it's additional material. But if you sand it, then that's fine, because you are not adding material. If you polish it, that should be fine if it dries properly. If you use Polysmooth and you polish with IPA, then if the IPA 100% vaporized, then there is no more additional material. So that's also fine. If you anneal it, that's also fine, because you are not adding additional material. So post-processing, yes, as long as you don't add materials. I mean, add a foreign materials, not the one you have already. It's sphere with the spring-like system, like TPU around it. Yeah, I mean, to be honest, there is one particular way that I'm thinking about that should win the competition. I think if one of you think about it, it should win the competition, but it goes outside the box. It's a little bit like the hook contest. Only the people that thought about, that spiral design, even though there is some controversy in some of them, so we will clarify that in our new competition. But yeah, there is one way. I don't want to say it because if it's a competition that you guys like and we really do it, then I don't want to spoil one of the idea I have. So I do have an idea. I think I will participate, but as a outsider, let's say, like maybe I will go against the winner. But that could be interesting. I think some sort of inbuilt complement spring, hidden spring loading mechanism that activates on impact. Yeah, that's actually a good idea. That's not exactly my idea, but Abdullah, you have an idea. That could be, but you know what's the problem is it will be dropped from a random position. So let's say you have one spring that is activated that direction, then it will touch, then it's fine. But if you put it this way, then the mechanism will have some issue. So you will have to solve the problem of the fact that it will be randomly positioned. Or you just put a way that, there's another way. You can have a mechanism that goes one way, but we are going to drop it from a certain height. So you just put a little bit more weight where you want it to hit, so that during the drop, it will just align exactly like you want. And then it will hit, and then the mechanism will be activated in the right way, and then it will happen. Yeah, that's a good idea. Well, I really start to like this idea of competition. What do you guys think? Oh, Claro is saying, I love it. Yeah, I love that competition. I think that's something we should do. Coley Logan, sounds good. Build the marks, there can only be one. Oh, Build the marks, thank you for joining. Must be pretty early for you, no? This morning I was on the LM show giving away some spool. And now you're joining on the other side. I was in the chat. Now you are in the chat. That's so funny. Noah, wired Ethernet would probably be better for stream. Yes, that's definitely. Actually, I should have thought about this. Actually, I have an Ethernet plug just behind. Yeah. Matt German, but should make it like a tear through, maybe to the heavy side, slam down first. Yeah, exactly. Santiago, from what height will it be thrown? I don't know yet. I don't want to say too much because otherwise you guys will have the advantage because you will know, so you will start to design. But you know what? I think I'm going to do it. I think we are going to do that competition. So I will work out the rules a little bit more because a lot of people didn't like the fact that they need to send to us. A lot of people didn't like that we say that it was our material, so they complained because they had to buy our materials. Some other complained because they didn't have a 3D printer to print. So a lot of challenge to solve to make the competition again. But I will think about it. Maybe we can have some third party, or maybe we can just do it again, but just for people with 3D printer. Maybe we can have a special discount for people that want. But this time we are going to open for all Polymaker materials. Whatever Polymaker materials you have, you can use. Not only Polymax PLA like last time. Yeah, the more I talk about it, the more I want to do it. Ola hook design. Yeah, good idea. Abdullah, balancing using weight. Yes, yeah, actually you guys had the idea before me. Technivorous, love 3D print live stream. Oh, Technivorous also have a nice YouTube channel talking about 3D printing. I still remember sending a couple of samples to Technivorous. Thank you very much for joining the stream. We are streaming every week. We are talking about the science behind 3D printing. Sometimes we are going very technical, whether we explain what is really warping, where does warping come from, what is oozing, what is stringing, what's the difference, what is clogging, jamming, all of this. Today we talked about our TDS, what's tensile strength, tensile modulus, impact strength, no impact modulus, bending strength, bending modulus, how to test material, all of this. That's on the Polymaker live stream every week. Hey, you guys passed 15K subs. You almost have as many as me now. Great job. I fully expect you to up me soon. Yeah, I mean, the goal is that in general we have more and more people that follow 3D printing content so that we can grow our community a little bit more. I'm so happy that we have more and more 3D printing channel so that we can grow our 3D printing community. My Tech Fun, I love it too. Yeah, I mean, Technivorous, if you guys don't know Technivorous, you should definitely go and check out his different video. He has tested some of our materials as well, and he tested some other materials. So it's a very good way to have an idea of how to compare materials. So you guys go and check out. Build a Mark. And we are very thankful for your generosity to the show and helping the build community. Yeah, definitely. To build the community. I'm so happy to support the LM show and to be one of the official sponsor now. Polymaker is the official sponsor of the LM show. Does the object have to stay in one piece? Collie Logan, I think you are starting to go towards my idea. You are starting to go. I never said in the rules, I never said that after touching the ground, it has to stay in one piece. What I said is it has to start in one piece. So maybe you got something. Santiago, well, as someone comes with an aerospace carbon reinforced peak or something, that wouldn't be fair either. So that would only be the Polymaker materials. So I know some people complained last time that we only required our Polymax PLA, but hopefully the fact that we open to all our materials and now we have very affordable materials as well, hopefully that will lower the challenge of only having one specific material, which at that time was Polymax PLA. What do you guys think? Do you think it's still not good to make a competition where we require people to use our materials? Do you think we should open to any materials? Yeah, what do you guys think? So we had complained about using Polymax PLA. So we are going to try to have some ideas on solving this. We have complaints on they had to print the model and sending to us. So what we did is we have a lot of different relay. So people in the US would send within the US, Japan would send in Japan, Australia send in Australia, Europe send in Europe, so that you don't have to send across the world. And then we would pay for the shipment to send to here. So that was another complaint. They had to print themselves. Fortunately, we had a lot of creators. I remember Sean, 3D Print General, Stefan in CNC Kitchen. They printed some models from design from their community. That was very nice. So that was another complaint. I think that's it. I think that was the two major complaints of our last competition that we would like to solve. So if you guys have some ideas on how to solve this, just let me know. Matt German, but the material to be all plastic, the mechanism. Sorry, I didn't get it. But yeah, it has to be only one type of material, and it has to be in one piece. Collie Logan, after impact, if there is no rules that it cannot break, then why not? If breaking is an idea, then why not? Just stay within the rules. So in the last competition, we play a lot with the rules. So playing with the rules is what we want. We want people to find ways to counter the rules. It's our job to make the rules in a way that we limit some of the some of the ideas. But the goal is we don't limit it too much so that people can still be creative. Technivorous, keep up the great work. I'll be back. Yeah, thank you very much. Thank you very much. I will join a little bit more. I think you are doing more live stream, if I remember well. Technivorous. I don't know if you're still there, but if you are making a live stream, just let me know when you live stream, and I will try to join as well. It's lagging again. I'm so sorry. I don't know what is happening today. Maybe the internet is bad. Maybe it's because of the Winter Olympics. Too many people in China. Well, even without the Winter Olympics, there's already a lot of people in China. Collie Logan, that's what I thought. Where you were hinting at. Yeah, definitely. Abdullah, limit to Polymaker materials branding. I mean, you know, limiting to Polymaker materials means limiting to 30 different kind of materials. I mean, is that still limiting when you have access to more than 30 different materials? I don't know. How about if you print the models we send you with a deposit to prevent infinite participant and a picture of the model printed by themselves? That could be for the deposit. I don't know what you meant by deposit. If it's money related, we cannot, at least not in the US, and I think in Europe as well. The problem with printing ourselves is a lot of people wants to control how you print, and sometimes how you print it is very important, the setting, and we don't really want to have so many people come to us with, you have to print like this. So it's a lot of work for us too. So one idea we had is we could bring a 3D printing service partner, but again, that might be a lot of work for them too, to control at such a level all the setting. Matt German, your sound is lagging for anyone. Object can be, yeah, I'm sorry again. I mean, it's almost the end of the stream now, so I will definitely work on having a better internet for next time. Object can be multi-parts, correct, as long as it's one material. No, Abdullah, the object has to be one object, so everything has to be linked with each other. Has to be linked with, not a string. We'll have to define the rules properly, but I want the part to be one part, not a part with a floating part inside or something like this. So, yeah, it has to be one part, one object. Print in place. Print in place can also have multiple parts. So it has to be one part, like the hook. It has to be one. Yeah, no screws, but still, you cannot have, like, for example, you cannot print this. Like if you have two circles, but they are not connected to each other, even if they are embedded like this, it's still two parts for me. So it has to be one. Okay, guys. Brian Firmer, enjoy the stream. I appreciate your insistence on the science and knowing why. Yeah, definitely. That's what we are doing now. That's what we will be doing every week. And by the way, I have an idea. I really like the fact that you guys are coming often, and I would like to reward the fact that you guys are very are very loyal to the weekly live stream. It's very nice to talk to you, and I like the fact that you guys are sharing with me, and also you are answering others' questions. So what I want to do is, at the end of each stream, I would like to give away one spool of filament, and this spool is one of your choice. So if you want to go for the most expensive material, so it has to be under 1 kg. We are not going to send our 20 kg spool, right? So it will be under 1 kg, but you will be able to choose whatever you want, and we will ship it wherever you are. Santiago, I know you are in Colombia. If you have a US address, that would be great. But if we have to send it in Colombia, we will do it. If you are in Europe, if you are wherever you are, we will ship it to you. So what I'm gonna do, starting from because not this stream, because I don't have any tool to randomly select one, but started from the next stream, I will have a tool that will allow me at the end of the stream. So whoever made it to the end, I will just randomly select one, and then you guys will be able to tell me what spool you want, and then I will just ship it out to you. What do you guys think? I guess you guys like it, right? I hope you like the idea. I hope you like giving back a little bit to you guys for being loyal to the live stream. I mean, it's been 9 live stream. I think it's the 10th one since the last year live stream, and I've seen your name pretty much every single time, and that's just so nice. Looking forward to more polished rules. Yeah, I will work out the rules a little bit more, and then I will send out the notification. I will talk with the team to see if they like the idea, and then we'll come out with the competition. Thank you for sharing your knowledge with us all. Much appreciated. Bichi Cognito. Thank you very much. Abdullah, revisiting shirt ideas we were discussing last time. How about this? Don't be a monomer. Join the Polymer Club with Polymaker. That's amazing. I love that. I will copy paste that. I want to keep that. I love that idea. Did you think about it for the whole week, or did you just come up with it just now? I will put that here. I want to keep that. That's awesome. I hope you don't mind. I'm going to take that idea. I won't be able. I hope you don't mind, but if you don't mind, I'm going to take that idea. I love it. I don't know what the other guy, what you think, but I love that idea. Don't be a monomer. Join the Polymer Club with Polymaker. That's amazing. I love it. That's definitely going to be a t-shirt. Hell yeah. Santiago, we love the idea. Love it. Sounds awesome. Sounds like a cool t-shirt. Okay, so you like the idea of the giveaway for the spool, and I guess you like Abdullah's idea. Yes, of course, Abdullah. Thank you. So I'm going to take that idea, and I'm going to make a t-shirt out of it. And I'm going to send a free t-shirt for you, just to thank you for this idea. Came out right after the session where we're discussing the t-shirt. Okay, great. If some of you have some more ideas about the t-shirt, just let me know. And if the idea is taken, if we love the idea, we will make sure to send you a free t-shirt with that idea on the t-shirt. Okay, thank you very much. There's a lot more to say on the TDS, but somehow we always end up talking about some other stuff. I wanted to talk about, because there's the physical properties and the mechanical properties and the chemical properties. So there's 3 different properties. And then in the physical property, you have the density, the melt index, the light transmission, flame retardancy, the chemical resistance. Oh my God. I think we'll have to do a 6-hour weekly stream in order to talk about what we want to talk about. Otherwise, 52 hours, which is 1 hour per week for the whole year, is not enough. We'll have to find a way to share more. Definitely. Okay. Thank you very much, guys, for joining the stream. Like I said, next week at the end of the stream, I'm going to give away a spool. Every stream, I'm going to give away a spool, and you can tell. If you tell me PA12CF, which is the most expensive material of our portfolio, I'm going to send it. I'm going to send it to you. So thank you very much again for joining. We are streaming every week, Thursday, 8:30 EST. And then once every month, we are streaming around that time, which is 7 a.m. EST or 10 a.m. Yeah, I don't remember. But once a month, it's more friendly for Europe. Okay, again, we are talking science. We are challenging 3D printing materials. We are trying to learn more We are trying to develop our knowledge, and that's what we are doing every week. So thank you, and then I will see you guys next week.